Hey, Sam's here, standing in front of Mr. Fulmore today. So we are going to do an introduction to functions. So you guys have this sheet printed 2-on-1, front and back. You are going to be working through examples and following along in my video, and then you are going to have your independent practice to complete by yourself, 1 through 6. So again, you're going to follow along on this sheet. All of this, a guided practice with me. This portion with me, when you turn it over, you have example and vertical line test with me, and you're going to do your independent practice by yourself. I printed them larger print so you guys can actually understand and see from the video. So first thing is first, we are going to start with our guided notes. A function is a relation in which each value of the independent variable is associated with exactly one value of the dependent variable. The independent variable is the input and the dependent variable is the output. So I have heard that you guys have listened and been taught the equation y equals mx plus b, where m is your slope and b is your y-intercept. Okay, this information is given to you in a graph or also in an equation. What they're talking about being the independent variable is your x, because it's what is being multiplied, so it is your input into the equation. And your dependent variable is your output, it's what the equation is equaling. So once you put x in, so you're going to take your slope times x plus your y-intercept, and your output will be your y value. This will also give you an x and a y to plot on a coordinate plane. So that's where we're going with this lesson. Okay, the next part, it is customary to let the independent value be x. Basically, I just talked about that. And the dependent variable being y. Each input, which again is x, must be paired with one output, which is y. Functions may be represented in various ways. Equations, y equals x squared plus 3. So right now in this one it looks like it doesn't have a slope, but I'm sure Mr. Fulmore has went over that when you don't have a whole number in front of your variable x, there's an invisible or understood 1. So your slope in this case would be 1. Okay, why is this a function? Let the input be 5. The input is x, so replace x with 5. So let me again reword that. So we're trying to figure out if this is even a function or not a function. So we're going to let the input be 5. If you go back up here, the input is always customary. That's going to be x. So what that means is I'm going to input 5 in for x, or replace, or I'm sure you guys have heard the term plug in. So where x is, I'm going to put the number 5. So I'm going to do 5 squared plus 3. Okay, 5 squared is 25. 25 plus 3 is 28. So my input was 5, my output was 28. So your value of y is 28. How many outputs did you get? I just got one answer because there can only be one answer. 5 squared is 25. I add 3 to it. The only number possible is 28. So I got one output. And each input will give exactly one output in this case. I cannot put in any other number in order to get 28 that you know of yet. We'll get to one where you will be able to figure it out. But anyways. So we have put in one input, that was 5, to get one output, that was 28. To better help you understand the next part that we're going to go to, you can create an ordered pair. So our input was 5, that was our x value. Our output was 28. So again, we had an x, we had a y. We put in 5 for x. We put in our output that we got after we put in 5 was 28. Because again, we did 5 squared. 5 times 5 is 25. That does not mean 5 times 2, if you go back and remember your exponents, 5 times 5, that's the expanded form of 5 squared. 25 plus 3 is 28. Okay, Number 2, you can also have tables in ordered pairs. So each input has exactly one output. Same case in this case as well. Okay, these are functions, and this table is not. So it says explain why this table does not represent a function. So I want you guys to take a couple of minutes with self-think time. Okay, I want you guys to examine this table. Why could this be a function and this one is not a function? Okay, so I hope that somebody actually paused the video and gave you guys some think time. If you remember, each input, which is your x, has one output. So -2, I don't see another input, gives me 10. 0 gives me 6. 4 gives me -2. So each input, -2, 0, and 4, only has one output over here. When I move on to this table, 4 gives me 10, 0 gives me 6, and 4 gives me -2. So this 4 value had two different outputs. It had 10 as an output and -2. So this is not a function because 4 was paired with 10 and 4 had an output of -2. So this is not a function. Okay, the number 4 had two outputs. And remember, a function rule, for each input, only one output. Had two outputs. Okay, so when you had input of 4, you got 10 and, keyword, -2. So there were two outputs. So we have an equation representation. You have tables in ordered pairs. And again, you were looking for every one output, or for every one input, there is one output. Okay, this example is also a function. Please do not get tricked on seeing 2 3s. They're in two different locations. So this is an x, this is the x, this is the x. So if I was to create a table off of this one, we have 1, 3, and 5. When our input was 1, our output was 3. When my input was 3, my output was 6. So I didn't have two inputs being 3. Yes, 3 was an output, but here 3 is your input. So for every input, there's one output. When you put in 1, you get in 3. When you put in 3, we got 6. When you put in 5, you got 9. Okay, our next section, functions may be represented in various ways, continued. We're going to look at two different graphs. Is the graph above a function? And then explain your answer. So, yes, this one happens to be a function. If you remember, for every input, there is only one output. So if you take a point, so let's say that this point is 2, 0. And this point is -2, 2. Okay, for every input, there's one output. So when you put in 2, the only value you get is 0. Like there's not another point that is on this line. When you put in -2, there's only one input. The only point on the line at -2 is right here, meaning -2, 2 isn't on the line that's graphed. It's down here, but it's not represented on this line. Okay, when we put in 0 for our x, our only output is 1. Like you don't have another point on the line somewhere down here or above it. It is on the line. Okay, so each x value, this is your explanation, what we just talked about, is paired with exactly one y value. Okay, on part B, also a function. Okay, so let's look at our x values. When we have -3, it's almost at -1. We have 0, 0, and 2, 2. So our x values, y values, -1, we're gonna, or sorry, -3, because this is your x, -3, -1, 0, 0, 2, 2. So the only y value at 2 was positive 2. The only value when x was 0 was 0. The only value when x was negative 3 was negative 1. Okay, you can also see, and again, sorry, your explanation is each x value is paired with exactly one y value. Okay, you can also see it in the form of a verbal description. So the cost of apples is $2 per pound. Write an equation for this function. X is your number of pounds, Y is your cost. So we have already kind of, or you guys have, looked at your unit rates. So you have $2 per 1 pound. So that's why it's represented here as your slope or your unit rate or your constant of proportionality. In 7th grade, you should have seen Y equals KX, meaning this is your constant of proportionality or your unit rate. This is your input. This is your output. So X is going to go here. So we're going to multiply our number of pounds. We're going to take our price, times our number of pounds. So we don't have a set value for our number of pounds. So we're going to use X. So when I look into this table, well, you have number of pounds is 1. So this is our input. So we're going to do 2 times 1. That's going to be our output because we have $2 per pound. So $2 for 1 pound of, what are we selling? 2 pounds of apples, okay, is going to be $2. Okay, here's our output. So our output is 4. So we have to get 4 for $2 times how many pounds is going to give you 4. Okay, 2 times 2 is 4. So for 2 pounds, my cost is $4. This one, our input is 3. So we have $2 per pound. So now we're going to multiply it by 3 pounds. And that output is 6. Okay, we can also graph the points. So we have an equation. We are able to make a table of values. 1 pound costs $2. 2 pounds costs $4. 3 pounds costs $6. And then we're also able to make a graph. So we have 1, 2. There should be a line here, but there's not. In here, actually. But anyways, so 1, 2, 1 pound. This is your cost here on your Y. This is your x-axis, your y-axis. So when x was 1, y was 2. When x was 2, y was 4. When x was 3, y was 6. Okay, so we're able to put points and coordinates on a graph. Okay, and give one representation of a function. You can write other ways to represent the same function. So we're going to plot our 3 points and then draw our line through it. Okay, again, when given one representation of a function, you can write the other ways to represent it. So we gave the equation as representation. From the equation, you could create a table by inputting your values, and for x, when given a table, you can also graph your image. So all 3 ways are representing the same exact function, which was $2 per pound.